Generating professional-grade video with Google Veo 3.1 requires specific control over generation parameters. Detailed text prompts alone cannot dictate the final render. This abstracted UI represents Google Opal, an experimental platform where many users first interact with Veo. You paste a detailed prompt into the text box, but the interface appears broken. There is no Generate button. The system ignores text input until the environment is defined. To activate the prompt, you must open the right sidebar and engage Advanced Settings. These configuration settings stabilize the workspace. Once the coordinates for the render are defined, the system acknowledges the text input. This logic flow shows the exact sequence required in Opal. By selecting an aspect ratio, like 16:9 or 9:16, and hitting the preview button, you define the canvas dimensions. Only then does the engine register the text and make the Generate button available. The required parameter control expands when we move to more robust editors like Adobe Firefly. Here, the system requires you to define both the exact visual resolution and the total time duration of the clip before it will render anything. Look at this data scale. A 720p video running for 4 seconds requires rendering roughly 100 individual frames. If you increase the parameters to 1080p for a full 8 seconds, you are multiplying the total pixel count and doubling the frame count, resulting in a massive computational block for the AI processor. Defining these limits forces the model into a rigid mathematical box. Instead of openly interpreting a concept, the algorithm must solve a strict visual equation with exact boundaries. Even with strict dimensions, text-only prompts struggle with temporal consistency. Without structural anchors, the AI guesses at the motion between frames, causing characters and environments to warp or morph unpredictably as the video plays. Tinker solves morphing by uploading starting and ending frames, allowing the system to calculate a direct mathematical path. Similarly, Google Vids injects predefined visual ingredients into a funnel. This avoids a branching tree of possibilities, forcing a single direct path to the final render. Let's test this workflow. We have a prompt on screen for a cinematic, slow-motion, waterproof watch ad. Before hitting Generate, there are 3 distinct parameter settings you must configure. Name them: the aspect ratio, the total duration, and consistency anchors. Correctly configuring these settings ensures the resulting footage executes exactly to your specifications. We can apply these constraints inside Flow, an editor that operates on a daily credit system. To test the system's limits, we will use a complex prompt regarding a macro shot of a delicate marzipan roof being assembled. Veo 3 quality delivers maximum fidelity, but burns 20 credits per generation. However, by locking aspect ratio, duration, and anchors, the AI needs less power. The Omni model produces identical footage, stretching 50 credits across dozens of generations. This brings us to a 4-step operational checklist for all future generations. First, input detailed text. Second, lock the aspect ratio and duration. Third, anchor the scene with frames or ingredients. And fourth, optimize your model choice for credit efficiency. Accurate AI video production is the result of parameter management. The algorithm produces compliant results only when it is confined by rigid structural limits.